Good morning, everyone. I've been trying to make this video for the last week, but I literally lost my voice. Actually, it sounds a lot better this morning than it has done during the week. But anyway, so if I'm still a bit croaky, I apologize. But I was indecipherable yesterday. My voice was so bad. So we're going to cover HA today, and basically, we're going to cover HA, split brain, and QDevice. So these are the topics. So first of all, let's discuss what is HA and what is it not. We're going to talk about HA and HA group configuration. What are the most common typical failures that we can expect? And then we're going to talk about more esoteric failures, such as the classic two-site, therefore an even number of nodes problem, which can result in a condition known as split brain. And then finally, we're going to talk about QDevice and what is a QDevice, how to install it, and what does it do for us. So let's start by talking about what HA is. And in a nutshell, HA, high availability. So if we have a problem, what HA will try and do is bring back any virtual machines or Linux containers that you've configured to be under HA. So they don't all have to be under HA, but it will try to, if you lost a node in your cluster, what it would try and do is bring up any HA configured virtual machines or Linux containers, bring them up on another node in the cluster. All right, so one thing that we'll see as we go through is that HA is absolutely reliant on shared storage. You can't configure HA unless you have shared storage. So HA can't guarantee that it's going to bring stuff back, but it usually does. I mean, I'm sounding negative, but I just want you to be aware that it's doing the best that it can to get it back. So the requirements are a minimum of 3 nodes. Actually, that's not true, as we'll see later in the course. You can have a 2-node cluster and still have HA, but the typical recommended would be 3 nodes or an odd number of nodes. Okay, if you have an even number of nodes, then you have this potential problem of split brain. But don't worry, if you must have an even number of nodes, i.e. the 2-site scenario, then we do have a mechanism to actually make it appear as though we've got an odd number. We can get around that. And what is it not? Well, it's not fault tolerant. There are fault tolerant solutions out there in the marketplace if you have a whole load of money, but they are incredibly expensive. So HA is not fault tolerant, and HA therefore is not magic. It's reliant on your resilient infrastructure to enable it to work. Right, let's take a look at the most common, the most likely problem we're going to come across, and see how HA can help us recover from that. So, and what I've done is created 4 virtual machines / containers. We've got 2 HA, one HA virtual machine, 1 non-HA virtual machine, 1 HA Linux container, and 1 non-HA Linux container. But I've given them names for what we intend to do. So the way you configure HA is surprisingly easy. We go to data center, we go down, let me collapse these tabs so we can actually see what we're doing. But if we go to HA and click on it, it opens up, and in fact there are 3 tabs in total, or 3 fields. Now the first one is where you actually define whether or not a virtual machine Linux container is actually under HA control. And the next one, which we're going to do first, is where you can create groups. Now let me make it clear, this is completely optional. You do not have to create groups. If you don't create groups, then all 4 nodes in the cluster will be treated equally in terms of migrating or starting virtual machines in the event of a failure. But I'm actually going to create a group because I want to it's such a simple idea. I want to demonstrate groups at the same time as HA. So we will create a group. We'll call it our HA group because I've got no imagination. And we will simply choose all nodes. So we're effectively saying here is that our virtual machines will obey whatever it is we're about to configure, which is fundamentally that every node in the cluster is available. Now, Charger and Cobra, let's say that they're somehow or other related, perhaps in location or something like that. So we can use the priority to actually determine whether or not we want a virtual machine to go onto one of these nodes first. So our machines currently are on charger, and let's pretend that's where we'd like them to be. Okay, we would like them to be on charger if everything's fine. All right, and then we might say, and if charger's not available, then we'd like them to go on to Cobra. The highest priority, and a high number indicates high priority, is charger. So given the cluster's working perfectly, I want members of this group to run on charger. Okay, the next priority is Cobra. So if charger isn't available, then put him on Cobra. And then finally, I've said Mustang and Trans Am are the lowest priority. And what that means is don't put those virtual machines or Linux containers onto Mustang or Trans Am unless charger and Cobra are not available. So you can either put them on Mustang or Trans Am. Now, the way virtual machines get migrated in the event of a failure is that they'll do a pseudo load balancing. They'll just relocate them across the available nodes in the cluster where they have the same priority. So we just click on Create. We then go to HA, and within HA, we click on Add. And here we're going to add virtual machines or Linux containers to the HA mechanism. So I'm going to choose HA VM test 1. I'm going to put it in the group, HA group, and then you have a request state, okay? And the request is almost always put to started, and that simply means that as far as Proxmox is concerned, this virtual machine must be running. Now, alternatively, you can say stopped, which would do the opposite, which means you'd migrate it but not start it in the event of a failure, which could be a valid requirement. And you can also disable HA for this particular virtual machine. So that could be a temporary change that you made, disable it so that you did some maintenance on it or something like that. We can also specify the maximum number of restarts. So given a failure, how often are we, or how many times are we prepared to try and restart this virtual machine, which is 1, which is probably a good idea. You don't want a virtual machine continuously restarting, failing, restarting, failing. Similarly with maximum relocation, how many times am I prepared to try and relocate it? And again, 1. If it doesn't work, then I need to go and find out why. So we can add that. Then let's do the same with the HA LXC test, which is that one. Let's put it in the same group, and let's leave it at started, and let's leave it maximum restarts 1 and maximum relocate as 1, and then click on add. So now we have 2 machines which are both running at the moment, and the state that they should be in is running. They're members of the HA group, and they're currently running on charger. And that's it. We've configured HA. Now, fencing I'm going to talk about later on, but actually there's nothing you can do here. And I'm going to explain why a little later when we come to look at split brain, okay? Right, so what we now need to do, having set HA up, now we need to simulate a failure. So I have the node charger above me, on a shelf above me. I'm just going to pull the power on it, which is pretty aggressive. So you can see I've put a little terminal in front of our Proxmox screen, and I've got date plus %t, and what that will do is simply display the time. Okay, so let's clear the screen. Let's actually, I'm going to pull the power and at the same time, well, pretty well, hit enter, so we'll know what time the failure started. Excuse me a second while I disappear up here. Wow, that was aggressive. Okay, so I've literally pulled the power cable out of the back of charger. So let's actually come up and be ready with the time again. So we detected failure pretty much instantly. Okay, now let me tell you straight away that Cobra, Mustang, and Trans Am are all discussing this, and they're saying, "Hang on a minute, what's happened to charger?" And they said, "Oh, he seems to have gone AWOL." They went and checked whether they were quorate or not, and they still are. We've got 3 online and 1 offline. Okay, so at the moment they're still kind of happy, and they've also said to themselves, well, charger is the only, we don't know what's happened to him. It's possible he's gone offline, or it's possible he's got a communication problem. But either way, Charger is either crashed or Charger knows that he does not have Core 8. Any node that is running an HA VM or LXC, when it loses Core 8, crashes. And it's deliberate. It's part of fencing that we looked at. We haven't looked at, but we've sort of vaguely mentioned. So any moment now, Cobra, Mustang, or Trans Am should take over this virtual machine. We know that it's actually going to be Cobra that's going to take over. And the reason that we know it's Cobra taking over is because we set our HA groups to specify that Cobra had the highest priority. So it took 3 minutes, actually. All right, I don't think it did. Let's just get on the console of this and make sure it is actually running. Connecting. Yep, so that's started. It's definitely started. There we go. Okay, so, all right, let's not be too negative here. That took 4 minutes, all right, on Mickey Mouse hardware. Okay, now for a fact, I know that Cobra, Mustang, and Trans Am would not have done anything for 60 seconds at least in my previous experiments that I've done. The reason they won't do anything is because they want to be absolutely certain that Charger isn't suddenly going to appear again. So that 4 minutes is longer than I normally see. Normally, to be perfectly honest, I see a couple of minutes. And you might think, oh, no, I want it to start quicker than that. But no, you don't. The point being is you don't want this thing panicking in the sense of virtual machines going up and down all over the place and then finding out actually it was just a network glitch. So this is why it does take time. Like I say, 4 minutes is a little bit longer than I expected, but that's okay. As you could tell from my voice, I'll probably edit this a bit, but okay. So there you go. And notice it has actually moved them across to Cobra. Okay, I am now going to pause for a second because I'm going to bring Charger back up again. Okay, and then have a think about what you expect to happen. So excuse me while I plug it all back in again. Okay, I have powered Charger back up again, and now immediately look, the HA guests, that's HALXC and HAVM, have both started to migrate across to Charger. So hopefully that was educational. So that's the most common failure you're ever likely to get, and it's really straightforward. So you know how to configure HA, you know what to expect if a node that's running an HA guest crashes, then it will simply migrate. And where will it migrate to? Well, that depends on how you've configured your groups. If you haven't configured a group, an HA group, then it will simply migrate to the next available node in the cluster. Okay, and it's the next day. My voice was just getting worse and worse, so I decided to leave it a day and hope for the best, but unfortunately, it's no better. Anyway, not to worry, let's carry on. So what we're going to do today, today's topic is split brain. I desperately want to try and avoid getting bogged down with irrelevant details. For instance, the way that I'm actually creating split brain. I don't want to get bogged down in the detail of that, but if people are interested, I can always actually post the scripts that I have so that you can see them. Okay, so here's the plan. Now, the scenario is that we have two sites. We have site A and site B, and as a result of that, we have an even number of nodes, which is not recommended, as I keep saying. And I'm hoping now to demonstrate why this is not recommended. So we've got Charger and Cobra on site A, and Mustang and Trans Am on site B. And we have 4 virtual machines which are not under HA control. And we have 2 virtual machines which are under HA control. So if we come here and have a look, this reflects what we've got. Charger with 1 HA node and 1 non-HA VM, I mean not node. We have Cobra with a non-HA VM. Mustang, which is site B if you remember, with 1 HA VM and 1 non-HA VM. And we have Trans Am with a non-HA VM. And if we go and look in data center, in HA, I've created 2 groups. I've called one site A and one site B. You can guess what they do. But basically, I've said that anything in in site A should run on site A. So it should run on charger, preferably because it's got the highest priority. If charger's unavailable, switch to Cobra. If both charger and Cobra are unavailable, then it can run on site B. And then if we look at the site B, it's the opposite. We're basically saying that Mustang is the preferred and Trans Am is the next priority. And then if all else fails, fail across to the other site. So that's the idea. So if you look, I've created these as being under HA control, and VM 100 is on site A, as we can see here, and VM 101 is on site B. So that's the HA setup. Okay, so let's go ahead and break it. I've actually created a script called Split Brain, which is going to add routes from site A to site B to a non-existent router, and routes from site B to site A to a non-existent router. So in other words, the two sites will no longer be able to communicate. Now, let me just show you, and by the way, I'm using tmux, which is a really nice tool to allow you to do all sorts of really clever things. So I'm going to start off by just showing you the current routing table. So if I do IP route, you can see that we've just got a default route and a route to the local network, which is what we'd expect. If I now run split brain with an argument of enable, then I'm going to enable my split brain scenario. Takes a second. If we do an IP route, we can see that in fact every node has additional routes to the other site via what I'm calling a black hole, a non-existent router. Okay, so that's basically what the script does. So I'm now going to actually disable it, because I did just create split brain, all right, but hopefully because I was pretty quick, nothing particularly dramatic has happened on the nodes. So that's what we're going to do. So this is our setup, all right. So we've got our 4 non-HA VMs and our 2 HA VMs, and I want to actually set up a situation like this, all right. Now what I've put here is actually the rules of engagement for quorum behavior when you have HA. And basically this is it. Nodes with an HA component, and by that I mean a virtual machine or a Linux container or more than one, they will actually panic. Nodes with no HA components will basically freeze. Okay, so any running VMs will remain running, but non-running VMs cannot be started. Okay, so you've frozen that node in terms of cluster operation. Panic nodes, in other words, nodes that crashed, okay, when they reboot, if they reboot, will not restart anything after a reboot until the quorum is resolved, until we've solved the problem. And you can't start any VM. So you can see from this that this is a really bad situation. It's bad news. So here is what we're expecting to happen when we simulate a split brain. We're expecting Charger and Mustang both to panic, okay? Because they no longer have a quorum. They're both sites are non-quorate, so both will panic. Okay. In my case, my machines are actually configured to reboot in the event of a panic. They will reboot, but it's not necessarily a good idea. It may be better to actually arrange that if a server crashes, that it doesn't reboot, because we probably should sort out whatever's wrong with it. But that's the kind of choice that you have to make. Okay, so Charger and Mustang should both panic. They will go down. They will then reboot, but when they reboot, both virtual machines will not start. Okay, so Cobra and Trans Am will basically freeze, in the sense that you're no longer able to do any Proxmox type administration. Obviously the reason behind this, the logic in this, is that if you have two node clusters effectively, if you start making changes, then you're going to end up with 2 halves of this cluster which are no longer in sync. So the best thing is actually not to allow anything to change until you've actually re-established a quorum. Okay, so let's cause chaos and actually called split brain. So what I'm going to do is first of all run my split brain script with enable, and as soon as that's finished, I'm actually going to run a watch on a banner of the time. Okay, so what it's going to do is it's going to display in large sort of hash symbols the time incrementing every second, and what we should see is that Charger and Mustang, at some point the time should freeze, whereas Cobra and Trans Am the time should continue to run. My script also logs the start time of the split brain situation. So I'm going to start off by just hitting enter and then run this command here. Okay, so you can see the time incrementing slowly as we go along. Now if we go back to our browser, already we can see we're on 232, we're on Cobra, I think that is, but anyway, we're on one of these two servers, and we can see that that we have a split brain situation. And if we nip across to Trans Am, oh, it's actually failed to expand, but you can basically see the same situation. So either side of the cluster can't see the other side. So let's return to the terminal. And in fact, you can see here that these have just panicked. Okay, so those nodes have panicked. Okay, and let's remember that time, 20, let's say 11:40:20. What did I call the file? Start time, cat start time .log. So 11:39:14 to 11:40:23. So it took a minute to panic. Okay, which is perfectly acceptable. Okay, so these at some point will have come back. Okay, I think we'll need to, in fact, there's a connection error. Do a refresh. There we are, we're back. So Charger's back. And if we go on Charger, go to open a shell, do an uptime, we can see that it's been up a minute. And if we go on to Trans Am or Mustang, it doesn't matter which, open a shell, do an uptime. Mustang's been up a minute. And if we look at Trans Am, uptime has been up 2 days. And if we look at Cobra, so we need to go back here, uptime, and that's been up 4 days. Okay, obviously I've been messing around with the cluster, banging them up and down, but you can see that Charger and Mustang both panicked. As expected, nothing has come up on Charger. It's completely frozen. Cobra, its non-HA VM remained up. Let's just confirm that we've got exactly the same type of scenario on here, and we have the HA and non-HA on Mustang have both stayed down because Mustang is completely frozen, and on Trans Am the non-HA VM has remained up, so it hasn't restarted or anything like that. It's remained up. So I now want to actually go on the console of this machine. Hopefully I can remember. I think I created a user called John who should be a sudo user. Whoops, sudo -i, and I'm going to power this down. Okay. Sorry, power off. So I'm going to power off Virtual Machine 105. I'm now going to try and start it. And it says, error 500, cluster not ready, no quorum. It shut off the screen very quickly. But you can see that basically you can't do anything now. Okay, we could shut down that VM, but we can't restart it. Okay. And that basically is a demonstration, a description and demonstration of split brain. So the next thing we need to sort out, what we need to sort out now, is how can we avoid this? Okay, I've got 2 sites. I'm a large organization. I've got 2 data centers, and I don't want an odd number of nodes on one site compared with the other. I want them to have the same. I want them to be balanced in terms of the number of nodes. So how can we solve this problem? Well, let's look at that next. Okay, well, the way that the cluster actually synchronizes its configuration database and all its VMs and this current state of affairs, but the way it synchronizes is using something known as CoroSync. And CoroSync is an open source synchronization mechanism for clusters, and it's actually what handles, amongst other things, the quorum mechanism. So Fortunately, they provide something known as a QDevice. Okay, a QDevice is basically not a physical device, it's actually a daemon. It's a process, a service you'd call it in Windows, that runs on a remote node somewhere, which is not part of our cluster. So this could be, it needs to be Linux, by the way. It needs to be a Debian or Red Hat / Fedora type install. So that does cover an awful lot of distributions. A lot of them are based on either Red Hat or on Debian. Okay, so it could be a mail server somewhere. It could be a web server somewhere. What you do is you install a package which consists basically of a daemon, and that daemon then you configure it so that that becomes part of your cluster. So it becomes a virtual fifth node. Okay, it can run on a VM, obviously not within the same Proxmox cluster. Well, it could, but that would be rather strange, wouldn't it? Or it can run on a machine that's actually doing a day's work, some other type of job that it's doing. So it's very simple. And what's the net result of this? Well, the net result is that then we have an additional vote which can resolve our split brain situation. This remote daemon will bind to either one half or the other of the cluster, but guaranteed not to bind to both of them. So one half of the cluster will win. I'm showing it as being Mustang or Trans Am, but equally it could have been Charger and Cobra. Okay, but in the event that it was Mustang and Trans Am, they would now be in a Core 8 state. Charger and Cobra would be in a non-Core 8. In fact, the way they behave is identical to what we saw in our little demo a few minutes ago. So if you recall, Charger panicked. It did not start any VMs at all. Okay. Cobra continued to offer the service of any VMs that it was running that were non-HA, but it's in a frozen state, so it can't do anything else. The cluster with the Coruscant daemon attached to it can continue to work now, so it will take over control of the HA-VM1, which originally was on Site A. It'll take control of that and start it up. Whether it starts it on Mustang or Trans Am is debatable, but probably Trans Am, simply because the Coruscant daemon does sort of basic load balancing more by spreading the numbers out than actually trying to work out whether one VM is more heavily loading than another. So it's a very simple load balancing mechanism. And that's it. So we now have our cluster back up. When we've sorted out our communication problems, everything will fail back to how it originally was because of the way we've configured our priorities when we set up these HA devices here. Okay, so it's that simple. Well, it turns out that it's almost frighteningly easy to do. So looking at this diagram, you can see that on the cluster itself, we install a daemon which is called Coruscant-QDevice, and that's a daemon which is a background process, a service in Windows speak that runs all the time. And it communicates with another daemon called the QNet daemon on the remote server. Okay, so all we've got to do basically is install those daemons and then configure the connection between the two. So it's a very simple process. Famous last words. Demos always go wrong when you say it's really easy to do this, but here we go. Okay, so what you do is you get on your cluster. Well, in fact, we start off on the non-cluster node. We should always do an APT update and then do an APT upgrade anyway, so we should keep our servers up to date with updates, sounds reasonable. And we simply do an APT install Coruscant QNetD, nothing else, that's it. Okay, well actually there is a step that you need to do, and that is when we actually configure the QDevice, we need to make a connection from the cluster to your remote host, what I'm calling a remote host. So it needs to be able to log in as root to be able to configure all this and set it all up. So what we'll find out is that when we do the apt install Coruscant QNetD on our remote host, it actually creates an unprivileged or a non-privileged user, and that is the user that will run that daemon. So that's good. But the cluster needs to connect as root initially to exchange keys and to just basically set everything up. So another step on that remote host is to either enable root login So you know, there's in etc sshd underscore config file, there is a line that says permit root login. Okay, so that by default would be no. So you'd need to change that to yes, and you would need to do a systemctl restart SSH. Personally, I'm not prepared to do that. So what I've done on my cluster is I've taken root's public key off the remote host, and I've installed it in the /root/.ssh/authorized keys file. So basically, I've allowed every node in the cluster to connect as root on my remote server, but I can remove that key immediately after we've done this. And then what we do is we come back to the cluster. On each node on the cluster, we actually install corosync-QDevice. Okay. Once we've done that on one node and on one node only, we run pvecm, which is the Proxmox Virtual Environment Cluster Manager command, with an argument of QDevice, setup, and then the IP address or host name of our remote server. So it's pretty easy, assuming nothing goes wrong, and it usually doesn't. It's a pretty easy process. So let's just do it. And then once we've done it, by the way, we're going to create the situation that caused split brain last time and see what happens. Okay, so I have a session on my remote server. We should do an update and an upgrade if it needs any update. Okay, having done an apt update, we're now going to do an apt install corosync, if I could type right, corosync-qnet daemon. Okay, and you'll notice that it's basically gone through and no errors, everything's wonderful. The only thing it says of any consequence is that it's generating the key pair. So it's actually generated a key pair that will be used between the cluster and this remote device. So that's that. So now we go back to the cluster and we do simply apt install corosync-QDevice and hit enter and look out for any error messages or anything, of which there should be none. Okay, so we now do a pvecm status, so that's plus Proxmox Virtual Environment Cluster Manager status, and this will tell us all about our quorum. And at the moment we can see that we have, instead of just 4 devices listed, in other words the 4 nodes in our cluster, we now actually have 5. So at the bottom of the list down here we actually have the QDevice now mentioned, which wouldn't have been there previously. Okay, right, so the next thing we need to do is actually connect to that remote QNet daemon, and to do that we need to actually set up the QDevice. Okay, now you only do this on one node, and the command is pvecm QDevice setup followed by the name, assuming it's resolvable, or the IP address of the remote QNet daemon server. And remember, you only do this on one node in the cluster. Okay, so now it's actually importing keys. So it's doing charger, and this is the point where it would fail if it was unable to log in. So it's done Charger, Cobra, Mustang, and Trans Am, and it's actually starting the QDevice daemon on all nodes in the cluster. Let's do a pvecm status again, and this time we'll go over what it tells us a little more clearly than I did last time, because it's more interesting. It comes down and tells us about the quorum, and it says we expect 5 votes. The highest number of votes we expect to see is 5, and the total number of votes is 5, so it's 5, all right? Okay, now before, if we'd run this, and I should have done, I forgot to, it would of course have said 4, all right? And it tells us what the quorum is. It says the quorum is 3, okay? So the minimum number of votes required is 3 to be in a quorate state. And by the way, further up on the screen it says we are in a quorate condition. So it says quorate yes. Okay, down here it tells us the members of the cluster. So it's showing all the members of the cluster, and notice we now have QDevice as being a member of the cluster and having a vote of 1. which is cool. I mean, that's the whole point of this. So now we've got 5 nodes, so to speak, although only 4 of them will actually support VMs and LXCs, etc., etc. One of them just sits there quietly. And as far as my remote server is concerned, it's really not going to do anything unless it's asked to give a vote in the event of a potential split brain. That's all. Over at the browser, if we look at it, actually, we might expect to see some reference at this point to the number of votes in the quorum, and we apparently don't. It tells us, yes, we're in a quorate state. Yes, there are 4 nodes online, because the QDevice is not a node. I mean, yes, it's an additional quorum vote, but it's not actually a node in its own right. So within the GUI itself, I've never been able to find a reference to the QDevice, but that could be just, maybe I'm missing something, but I genuinely have been unable to find any reference. However, on the command line, we can see that it's working, and better than that, we're going to break the damn thing. Okay, so now we actually see that we've got a QDevice. Let's actually create the situation that previously caused us to have split brain. Right, and what I did, if you recall, is I ran a script that I've written called split brain with an argument of enable. And what this does is adds 2 routes from site A to nowhere if you're trying to contact site B, and vice versa. Now, it was important that I didn't just break the routing table altogether, because all these 4 nodes need to be able to talk to Kukang, the QDevice server. Okay, so if they lost connection to Kukang, then this whole quorum mechanism, additional vote for the quorum mechanism, unfortunately wouldn't work. Okay, so what I'm going to do is enable that, all right? And then, okay, we run an IP route, and you can see that all nodes in the cluster have got 2 additional routes. One from the guys on site A can't talk to site B, and vice versa. If we now switch to the browser, and if we have a look, already we've noticed, so let's go on Charger first. So Charger and Cobra have noticed that Mustang and Trans Am appear to have gone down. Actually, they don't know what's happened. All they know is they can't talk to them anymore. And if we switch to Trans Am, then it's the opposite story. On Charger, it's Charger and Cobra that appear to have gone down. So let's switch back to our terminal, okay, and let's see. Now, at the moment, all 4 nodes appear to be up. So let's do a PVECM status. Oh, it looks like Chargers actually fell out of the sky. Okay, so Chargers panicked. We can guess that, but I'm pretty sure that's what's happened. If we run a PVECM, we can see the Cobra, okay, Cobra is basically saying, right, I no longer have a quorum. It says quorate, no. And it says the higher expected votes is 5, highest expected is 5. Quorum requirement is 3. And in fact, down here, it's telling us that we've actually only, up here, I should say, we've only got 1 vote. Okay, so activity block. So now let's go and look at the GUI and see what it thinks is going on. Okay, so remember, depending where you are logged in the GUI, will affect what view you have. And here I'm logged into Charger, so it thinks, well, it can't communicate with Mustang and Trans Am, but it panicked, it came back up, and it hasn't started anything. Cobra hasn't done anything, it's just sitting there. But neither of these pair have a clue what's going on the other side, but they do know they do not have a quorate. If we go and have a look at Trans Am, we can see that they do have a quorate, as previously discussed, despite the fact that it shows it here because it says that we are in quorate and that there are 2 online, 2 offline, but it doesn't actually give us a clue as to how come we're still in quorate. And here we can see that we have HAVM 2 running on Mustang, and HAVM 1, which is the one that was running on Charger, is now running on Trans Am. So it's done this kind of fairly crude load balancing. We've avoided split brain. How exciting is that? Simply by installing a daemon on every node in the cluster. Let me remind you, that's the QDevice Corusync-QDevice daemon, and a daemon on our remote server, which could be a Raspberry Pi. So you can genuinely use a Raspberry Pi. So in a home lab, Yeah, use a Raspberry Pi. Okay, so it's really easy to do. Install QNet Daemon on your remote server, QDevice on your cluster, each node in the cluster, and then on one node and one node only, install run the setup command. I don't know if you heard that in the background. Alexa is reminding me.
This is a reminder. Dustbin.
Alexa is reminding me that tomorrow our dustbins are emptied. So you'll have to excuse me while I rush and put the dustbins out. That is it. That's this section. I don't know how long this is going to run for. I'll try and edit it down to something sensible. But I hope you found that useful. Please do subscribe. Please do leave comments. I mean, I've had a few people leave very nice comments, and I'm grateful for that. It's nice to know that somebody's enjoying my little daft videos. But I'm quite open to constructive criticism. I have an incredibly thick skin, so I won't be offended if you basically say, no, you got it all wrong. And if I have got things wrong, then please tell me so we can put it right. Now, what I want to do in the next section is a tour around the file system and introduce a number of low-level commands. In other words, CLI commands, because I think it's really interesting. Proxmox is not obfuscated. It's not all kind of obscure and weird and wonderful. It's a bunch of configuration files. It's a bunch of simple, sensible commands. It really is easy to get your head around the command line interface. So that's what I plan to do in the next section. And don't forget, we've still got to do the Proxmox Backup Server. So don't forget to like and subscribe. I ought to do some fancy graphics with tick boxes and bells ringing like everyone else does, but I don't really think I'm into YouTube in the same way that some content creators are. That sounds a bit pompous. Is that what I am? Wow. Bye guys. Thank you for your time. See you next time.